Okay, so in this video, this is going to be the first video on Calc 2, and what I'm going to do is basically to try to motivate what all of the first chapter is going to be about. So the first thing you're going to do for this entire first chapter is learn a bunch of techniques to do integration. If you remember in Calc 1, the general strategy was to learn easy derivatives. Like for instance, you did x squared, you did the square root of x, you did e to the x, you did ln x, you did sine x, and there were a bunch of others. And then the way that you learned how to do derivatives was you thought of different ways of combining these in order to make new derivatives. So for instance, if I combine these two, I could multiply these two, in which you would use the product rule. I could divide these two, in which case you could do the quotient rule. And then we probably learned that you can combine them another way, where you put one inside of the other, and this is composition of functions, and you use the chain rule for this. So no matter what combination of functions you try to put in, the derivative you'll always have a rule that you can fall back on in order to find the derivative. Unfortunately, the same is not true for integrals. And that's what I want to talk about very briefly in this first video. So the next thing you would like to do is that you learn easy integrals, which is what happened at the end of Calc 1. You learned how to do x squared. Remember, that goes to x cubed over 3. You did 1 over x. Gives you a log. You learned secant squared, and that gives you tangent. You did e to the x, and that gives you, tangent x. That gives you e to the x. Now, you would like there to be a product rule, a quotient rule, a chain rule, for whatever combinations of these you can come up with. The problem is, this is usually impossible. Now, what do I mean by that? For certain combinations, like let's just take addition. You probably remember from Calc 1 at the end that if I want to add two integrals, I'm totally allowed to just do them separately and then add them. Now that's the same for derivatives. Now let's think about multiplication. If I try to do x squared times cosine x, there is no product rule for integrals. You're going to have to come up with something much more clever, and actually the first lesson you do will be integration by parts, which is sort of like a product rule. It doesn't always work. You have to do it a little bit carefully. So some of them are possible. And I believe you would get, I think it's going to be like x squared sine x minus 2x cosine x plus 2 sine x. I think I might have a minus sign off or something. But needless to say, you don't need to know how to get here. That's what we're going to talk about in the next video. But now I want to talk about, sometimes it can happen. Cosine x times ln x, let's say. If you needed to take the derivative of this function, that would be pretty easy. You just do the product rule. The problem is that this integral is actually impossible. We can actually prove that it's impossible. What do I mean by impossible? If I were to get an answer out the end of this, I got, I don't know, cosine squared 3x times ln x minus sine x over x plus 2x squared cosine x. Maybe that was the answer. It's not the answer. How would I check that that was the answer if I got that as an answer? Well, I should be able to start from here, take the derivative of this, and I should get cosine x times ln x. That's what integration is. The problem is, we've actually proven this. This is way beyond the scope of the course, but you can actually prove that no combination of sines, cosines, ln's, square roots, cube roots, fractions, secants and tangents, and anything you can think of, no e to the x, no combination, plus, minus, times, nothing that you could ever write down would ever have a derivative that is cosine x times ln x. So these integrals are impossible. They're impossible to do algebraically. It's not too hard to see that, you know, if you needed to find this integral is just an area. So you would be able to find like an approximation. You could ask Wolfram Alpha to give you an approximate answer to this integral, but you would never be able to find an antiderivative and then plug into minus plug in 1 like you're used to. So some of these integrals, I'm not saying they're impossible as in there's no area. There is an area, but just no combination of easy functions will give you an antiderivative. So, there's your spiel on how integrals are very different from derivatives. And that's what this next chapter is going to be about. You're not going to be able to show that these integrals are impossible. I'm just telling you this to contextualize it. Why do you have to be so much more careful? You're going to learn so many more techniques for integrals, and it's not going to be like product rule, quotient rule, chain rule. They're going to be weird. And the reason for that is because integrals are notoriously harder than derivatives. Some of the rules you can kind of reverse, not all of them. So that's what this next chapter is going to be about, and I'll see you in that one.